Good morning, pre-calculus. If you got today's text, you've already started by taking this problem here and making it into an augmented matrix. And if you have not done that, I'd like you to pause this video and not continue until you've done that. All right, so if you have continued on with the video, what that means to me is that you have written this augmented matrix and you're ready to go on. Keep in mind, our first goal is to get this value right here to be a 1. And then I'm going to keep my other two rows the same. So my question is, what do I need to do to get that to be a 1? Well, it looks to me like if I just simply subtract the first two rows, I'm going to get a 1 there. So I'd like you to pause and do that. If you have continued the video, it is because you have gotten this next matrix. Our next goal is to get a 0 here. I'm going to keep this row here and this row here the same. I want to get this to be a 0. What can I do to get that to be a 0? Looks to me like if I double the third row and add it to the second, I'm going to get a 0 there. So I'd like you to finish the rest of that row operation before you go on. If you have hit play, it is because you have our next matrix. With our next matrix, there's two goals here for the next step. I want to get this to be a 0, but I also recognize that this row right here is all divisible by 3. And so I'm going to ask you to do two things at once this time. I'm going to ask you to take row 2 and divide out that common factor. And then I'm going to ask you to try to get a 0 there, and I think we can do that by just adding row 1 and row 3. So if you have hit play, it is because you have this next matrix right here. Keep in mind, my next goal then is to get a 0 here also. And it looks to me like I can do that quite easily by simply adding row 2 plus row 3. And when I do that, I not only get a 0 there, but I also get a 0 there. And uh-oh, we had this problem yesterday where we got all zeros there. But what's going on this side here? Oh, that's also a 0, which is a different kind of kaboom. What does this mean? Ah! All right, so let's think about this. This means 0x plus 0y plus 0z is equal to 0. In other words, 0 equals 0. Oh my gosh, that's like flippin' always true. So, let's go back to this. Basically, what this is telling you is that we can let Z be anything. Z's got all kinds of potential. Z has high hopes and dreams big. Z can be anything. But Y is bounded. This equation here tells me that Y plus 2Z is equal to -3. If I solve this equation for Y has to be in the form -3 minus 2z or -2z minus 3. So Y has some constraints on it. And then if I look at this equation here, that tells me that x minus 6z is equal to -4. If I solve that equation for x is equal to 6z minus 4. So x also has some constraints. What these three things are telling me all together is that anything that's in the form 6z minus 4, comma, -2z minus 3, comma, z, where z can be anything and x and y coordinates are constrained, anything that fits this pattern is going to be a solution to our original system. But keep in mind, that means that there are indeed infinite solutions. It's not just anything you want it to be. It's got to be in this particular form, but there are infinite of them. Okay, so just like in Algebra 1, sometimes when we were trying to solve a system of how do two lines intersect, sometimes they intersect at a single point, sometimes they never intersect because the lines were parallel, and sometimes they are identical. So there are infinite solutions because the solution is the line. It's kind of the same thing. Sometimes I get a single point, sometimes I get no solutions whatsoever, and sometimes I get infinite solutions where the solutions are constrained. That's your lesson for today. I'm going to send you 3 practice problems. I would love if you would post your answers into Canvas. All right. Peace out, folks.